All right, let's get right into it. We're going to tackle some of the absolute fundamentals in C#. You know, if you've ever found yourself scratching your head about the real difference between a class, a struct, and an object, well, you're in exactly the right place. We're going to clear all that up using a simple idea: blueprints.
So think about it for a second. How do you actually build anything in code? I mean, you can't just start mashing keys and hope a program appears, right? Just like building a house. You can't just throw bricks in a pile. You need a plan. And in the world of programming, that plan is everything.
And this right here is the key to understanding all of this: the idea of a blueprint. A blueprint isn't the thing itself, right? It's the detailed plan for the thing. It tells you what it's made of, its properties, and what it can do, its behaviors. Seriously, keep this idea in your head because it's going to make everything else just click.
Okay, let's start with the first and probably the most common type of blueprint you'll see: the class. I want you to think of a class as the big, detailed, architectural plan for something really substantial, something complex, like a house. So, what makes this blueprint so heavy-duty? Well, first off, a class is a reference type. That's a fancy way of saying when you use it, you're not holding the house itself, you're just holding the address to where the house is. And where is it? It's on the heap, which you could imagine as this big, sprawling city of memory where all the large, important objects live. And because they're so complex, classes support inheritance, which means you can take an existing house blueprint and, add a new wing or a swimming pool to create a blueprint for a mansion.
And here's what that blueprint actually looks like in code. See, we're defining a class called car. It has a property for color, and we could add a bunch of methods like start engine or drive. But here's the crucial part. This is not a car. Not yet. This is just the set of instructions for how to build one.
Now let's look at our second kind of blueprint, the struct. If a class is that big, detailed plan for a house, a struct is more like a quick, simple, but very precise sketch for something small and self-contained. Think like a single Lego brick. And its features totally reflect that simplicity. A struct is a value type. This means when you pass it around in your code, you're copying the entire Lego brick, not just its address. It gets stored on the stack. And you can think of the stack as your personal workshop. It's super fast, super organized, and perfect for small, quick jobs you're working on right now. And because they're meant to be simple, they can't be inherited. This is what makes them so incredibly lightweight and efficient.
And here's what a struct looks like in code. You can see it immediately, right? It's just simpler. This point struct just holds two numbers, an x and a y. It's perfect for something like a coordinate on a graph. No fuss, no extra complexity, just the data you need.
So we've got our two kinds of blueprints, the big architectural plan and the simple little sketch. Now, let's put them side by side and really nail down the differences.
And here it is, the showdown. A class, that's your reference type, lives on the heap, supports inheritance, and it's best for your big, complex objects. The struct, that's your value type, lives on the super fast stack, no inheritance, and it's perfect for small groups of data. It all comes down to choosing the right tool for the job. Are you building a whole house, or do you just need a bunch of simple, efficient Lego bricks?
Okay, so we've spent all this time talking about plans and sketches. But you know what? Blueprints are pretty useless until you actually build something. And that is where the object comes in.
This is it? The object is the real deal. It's the finished house that you built from the class blueprint. It's the actual physical Lego brick you made from the struct sketch. It's the thing that takes up space in your computer's memory, the thing your program can finally work with.
This line of code right here, this is where the magic happens. See that little word new? That's the construction crew. It takes our car blueprint, goes out to the memory, and builds a brand new car object. My car isn't just a plan anymore. It holds our actual usable car.
All right, let's dive into one last detail, but it's a really important one that trips up a lot of people. It's about what copying actually means in your code. We need to separate three different ideas here.
Let this one sink in for a second because it's the key to everything. A variable is not an instance, and an instance is not a reference. They might look similar in code, but they are three totally different things.
Let's break it down. Step 1. First F. All we've done is create a variable. Think of it like an empty name tag, a label called F that isn't attached to anything yet. Step 2. F equals new first. Now we're building. That new keyword creates an actual instance in memory, and we stick our F label onto it. Now step 3. This is the critical one. First F2 equals F. We are not creating a new object. We're just creating a new label F2 and telling it to point to the exact same object that F is already pointing to. That's a reference copy.
So remember, every single time you see that new keyword, you are telling the computer, hey, go find a fresh block of memory for me. You are building one, and only one, new thing.
But when you just do an assignment like F2 equals F, you create 0 new objects, 0 new memory blocks. All you've done is create another signpost that points to a place that already exists. Getting this distinction right is absolutely key to managing your program's memory and avoiding some really weird bugs.
And that brings us to the end. So the next time you sit down to write some code and you need to create a new type of data, I want you to ask yourself this question. Do I need the power, the flexibility, the complexity of a class, that heavy-duty blueprint? Or is the speed, efficiency, and simplicity of a struct, that lightweight sketch, the right tool for the job? Because now you know how to choose.